How do you keep track of consumption in inventory?
Consumption on the customer side?
All of the above, yeah. Any place where you would have to put a capital investment in to expand it?
Okay. So we actually have, one of the interesting things about building this was that there's the user interface that the customer sees, and then there's the user interface that the rest of us see. And
That one's scary.
Yes.
Monolith.
So there are a number of capacity points that we actually have to keep track of. The scale-out cache in the POPs is very important to keep that healthy. The good news with that is that because we know how fast customers can push data, there's actually a speed limit. We can come up with a theoretical maximum number of days before we run out of space if everyone were to go full blast. So we keep track of space utilization for the caching in the POP very carefully, and that always needs to align with the lead times for getting new gear. The other thing that happens, though, because it's just a cache, we have the exorbitant privilege of just kicking out data. Most of the data in those caches is stone cold. So we can always just make space by kicking it out. There's a performance penalty, but if it is actually accessed, but that's an arbitrage, and for the most part, you don't see it. One of the interesting things that you'll see when you're doing performance analysis of even flash systems is that there are IOs, even on an all-flash system, that take 100 milliseconds or 150 milliseconds. So those would happen here as well if we had to repeatedly go to the cloud. So we're able to continue to run if we run out of space. So that's the good news. If the cloud were to ever run out of space, that would be a really, really bad thing, but we're hoping that doesn't happen. The other thing that we cared very deeply about, obviously, is networking. So much of what we do is premised on the idea that we're able to push all this data into the cloud very, very quickly. We do have that 10-minute interval, and so we have a very, very wide set of pipes, and we watch the network bandwidth obsessively. That is probably the biggest thing. We run a redundant network, so multiple 10 gigs going down to the cloud providers. And so if somebody wanted to be a cloud provider for us, it would be largely a consumption of ports. That would be the most interesting part of the exercise. And then finally, we actually have monitoring in every piece of software that we've written. And we've really spent the last year, ever since we shipped the initial release of the service, we've essentially spent the bulk of the last year really building out and perfecting monitoring. So we have extensive logging. We are actually finding that when something goes wrong in the customer site, we actually know it before the customer does. But we have an awful lot of very interesting analytical capability in terms of munching logs and finding relationships between statistical anomalies in various parts of the system. So, and we're getting better at that. It's not a pretty user interface, but it looks like a page on your cell phone actually, or Victor Ops or something like that. But it does the job.
Actually. Yeah. How often do you plan to change out the edge devices at the customer site?
So the financial model says we do it every 3 years, and in practice, and actually there's more to it than that. The financial model says every 3 years. We actually sized the caches for durability such that they'll last at least 3 years. But really depending on the wear, we probably have more than 3 years in them. And so the only reason aside from just being not serviceable anymore, the only reason you might want to change one out is because it's old technology and there might be something new and interesting that we have, like say NVMe comes out and we can get a better performance profile. And you have a 3-year-old cache, we would probably do something like that. But 3 years is what we tried to size everything towards.
Is that part of the agreement? So we're just talking over here. This is bordering kind of a managed services type arrangement. So is it in the agreement that every 3 years you swap it, or?
We don't explicitly put it in the agreement. if a customer asked us, we would just do it. As long as it's like 3 years old. If it's broken, we'll just do it.
Right.
We're not. In the end, it turns out that the cost of that edge device is actually relatively small.
Yeah.
Compared to everything else.
Yeah.
So it's much easier for us to be very forgiving if something is wrong or if something is old, we replace it. Because it doesn't really amount to much. It's not a huge portion of the overall storage footprint.
Is that edge device fully redundant?
Yes. So dual power supplies, dual controllers. Actually, pretty much even dual back planes. So it's actually it's a cluster in a box.
Okay.
Type
So
of
it's a
array.
lot like a dual head storage
Yes.
array with the back.
In fact, I believe that there was a large storage OEM that was using the same exact chassis to do a regular storage array. The difference with us is that it's a cache. So one of the neat tricks you can do with our edge device is you can pull out all the disks, every single one of them, and it'll still run because it's just a router into the network. In that case, so.
What's that migration look like for users who have, when their storage environment is hitting that cache, you're going to bring in another one. What does that switchover look like?
You bring in the other one. So we have scale out of the front end. So you bring in another one, and they start talking to each other. They normalize, and then once you decommission the old one, everything automatically moves over to the survivor. So it's non-disruptive. There's some cache rewarming that may need to happen, but the idea is that you have both of them running side by side for a fairly long period of time so that they normalize. The longer you run them, the more likelihood there is that there's no performance degradation when you remove the old one.
I think the architecture and the solution is revolutionary in a way, but I cannot stop thinking that it's heavily dependent on your geographical presence, and that at the same time implies a lot of investments in terms of point of presence, connectivity, and so on.
Yes.
So if you really want to expand globally and get critical mass to have this business continue and grow and be reliable, how do you tackle this challenge?
So two ways. So the first thing we did was to try and keep the size and the scope of the point of presence relatively small. So it's not a very huge expense, like order of like $100,000 or $200,000 to run a POP, to build out and run a POP for a year. Then you have to actually sell storage, that's the huge expense. It turns out. So the ability for us to expand out in terms of points of presence inside of the United States is actually relatively straightforward as long as we can get a sales team to be there to use that capacity, to actually sell that capacity. That said, we're starting to work with service providers to either host our service that's backed into the cloud, or it's a lot of service providers we're finding have their own private object storage clouds, which rival the size and scope. Maybe they're not as big as S3, but they're pretty damn big. And in those particular cases, they're able to leverage this type of technology to build out their own networks, and that's another way that we can.
So the backend the cloud backend doesn't have necessarily to be Amazon.
No.
Let's say that you want to expand your service where there is no local Amazon regional presence. You could do the same by making agreements with telcos that have
Yes,
their own.
exactly. We are sort of agnostic to the actual object storage in the back end. We use the Swift API, which is it's the Amazon S3 API. We have a fairly thorough document that we provide providers that actually want to look at hosting this type of a service, which gives the requirements in great detail. In terms of what APIs we use, how we use them, what's likely to happen if you don't have them. And we're trying to do, as we collect more and more information about the various cloud object storage clouds, is try and work around some of the more difficult, thorny issues. Things like consistency models and versioning, and there's all sorts of back-end APIs that are needed in order to get around particular problems with particular clouds. And so the document's relatively long, but we're learning more and more about how to do that correctly.
Another business model question.
Yes.
So do you plan, for example, if you want to expand in other countries, in other geographies, do you plan to also rely on telcos or ISPs to actually sell the service for you on your behalf?
Well, it takes a certain. We have so certainly in other countries we need partners. There are a number of issues that revolve around the whole data sovereignty issue that requires us to go into a particular country and have a cloud for that country. We haven't gone to another country yet, but when we do, it will be the Italian cloud or the German cloud or the British cloud. But it will be a single country cloud. It will need to be operated by a partner in that country, and a lot of the certifications that are required within that country need to be covered by that partner. So from a business standpoint, we're expecting to get leverage from partners in that area. Now, there are some areas that we don't have answers for because I can anticipate some other questions like, what if I'm a multinational company and I have, an office in multiple countries? There you have an interesting set of questions that need to be answered, and we just have to work on a case-by-case basis with partners to figure out how we can get data across borders if that's what's required.
But you will sell the service as ClearSky, not outsourcing it to, I don't know, Telecom Italia and, I don't know, Wind or...
Yeah, it's ClearSky, and we're startups, so we're flexible. If they want to white label it, that's perfectly
Fair
fine. But it's everyone will know it's ClearSky when they start to look at the edge cache and they look at some of the characteristics in the user interface. So,
how many point of presence do you have in the U.S. now?
we're on the East Coast right now, so it's Boston, New York, Ashburn, Virginia. We're going to have California and Dallas next. And then probably something in the upper Midwest. I'm thinking Chicago right now, but it's really driven by sales opportunities right now. We're trying to be nimble. And then, we initially said NFL cities. At the end, I think we can get the whole country with about 15-ish points of presence if we really wanted to. But there are all sorts of secondary markets, and I think the service provider community could probably help us expand greatly in terms of reach, even in the big cities, because some of the you have cities like Boston, which are relatively constrained. Then you have LA, which is it's not 2 milliseconds from end to end in LA, right? So there's a lot of space to cover.
Going back to the edge appliances, I believe you mentioned it flushes a cache about every 10 minutes, and
Yep, not in the edge, but in the POP.
oh, okay, sorry, the POP. So what would happen if you have a catastrophic failure on the edge appliance?
Well, the edge appliance is basically just a cache. So everything that was acknowledged as a write is living in that point of presence
Gotcha.
in the middle tier. So
So
you
it
can
just pull it
select
back down when you
Yeah,
slap
pull
the
it.
new one
Yeah,
in.
yes, put in a new one, or if you have another one in another location. So you never lose any data. That's one of the beauties of the architecture. You can lose all the disks. In fact, that makes for a great demo if we had one like sitting here. I mean, you take all the disks out, there are no disks, you're still seeing your data pass through. You're essentially getting the IOPS from the cache infrastructure in the POP, which is a couple milliseconds away.
Okay.
Or are you landing any writes on the cache, or is it all read?
It's all read. The writes all land in the POP.
So it's a true
Gotcha.
write-through cache architecture.
That's right.
Yeah. So that really isn't a point of failure
Yeah.
or a point of data loss.
No, you can't. Yeah, you could. There's nothing that could happen in your rack as a customer that would cause data loss because it's we have another copy of the data in the POP. We have in 10 minutes you have a copy of the data in the POP and in the cloud. So your data is protected.
And that's why you need to have locations with extremely low latency, because otherwise if you had higher latency, then your write-through cache would affect all sorts of performance, and then the whole house of cards would come down.
That's right. Yeah.
Yeah.
You would end up getting we are very, very sensitive to that radius around our point of presence. It turns out that's about a radius of about 100 miles or so. 100 miles is actually a pretty big circle in most metro areas. I can't think of many metro areas that would be challenged by that. I mean, there are probably some parts of Texas or California, like Southern California, but beyond that, I think...
If latency wasn't as big of a concern, could you have gear in one Equinix data center, use their cross connections between them to access your service as long as the customer understood?
Yeah, I mean, we've had those discussions. Yeah, if you wanted to do a 2 or 3 or 4 millisecond leg, yeah, we could do that. Latency would, it really affects, if you look at the way it works, it affects your write latency. Your read latency is predominantly determined by that edge cache.
Right.
And so,
Working set.
yeah,
Right.
so your write latency even be a little bit different. But if you have, especially if you have a predominantly read workload,
Yeah.
you probably won't even notice.
But even 4 or 5 milliseconds,
Yeah.
How long have we been doing this when 4 or 5 milliseconds was like crazy fast, right?
Yeah.
That didn't that long ago.
Well, yeah, what we were trying to do when we built the system is to come up with a performance profile that's as close to an all-flash array as possible.
Yeah.
And you can only do that within certain constraints.
Yeah.
But if that's not a requirement for you as a customer, we can take liberties with the length. It's the same system, and the POP behaves like a hybrid storage array in terms of it has a mixture of flash and spinning disk, and so you get a composite of that performance.
This feels very similar to conversations that I was having back around Y2K, around ATM routing, dark fiber.
Yes, I was there.
I'm having a deja vu moment. Like this is the kind of stuff we used to design with
I was
BGP and stuff like that in mind.
Yes.
Did you have, maybe were some of your engineers involved with some of that?
I was in the networking space in 1999. As a matter of fact,
Yeah.
I was at a company that was building edge routers, and
So 12,000 GSRs.
yes,
NK
those are
stuff like that.
the 10,000s, and so the edge was the big thing. You'll recall in those years. In fact, there was another company. Mark was from this company, is called Storage Networks.
So was I, by the way.
Yeah, that's right. You
I
were
was
too.
a
That's right.
I was a storage networks architect in Houston where we did Metro Fiber.
And so a lot of the core infrastructure was not in place then. So in 1999, you had places like Houston and Dallas where there was a lot of fiber, and then you had places where the fiber was non-existent. So you couldn't get the consistency that we can today. I mean, one of the things that's really changed is not only is the fiber there, but the economics of fiber they're starting to resemble commodity economics in the sense that the price is going down per unit bandwidth over the course of a year or 2 years. So it's a different world. Building what Storage Networks wanted to build in 1999 was a very expensive thing.
And it was expensive for many different reasons,
Yeah.
and most of those have been solved now with a lot of
Yes.
this. I mean, we were using fiber channel with real off-the-shelf fiber channel storage arrays.
That's right.
And those storage arrays were stupidly expensive.
Other people's stuff.
Yeah.
You sell that, it was complicated.
Yeah,
Yeah,
exactly.
What we're able to do today is most of the stuff has been commoditized. I think what's interesting about our concept is that we've taken a lot of sort of pay-as-you-go OpEx technologies and incorporated them into the service like a typical OEM incorporates disk drives and memory and compute. We have cloud services and networks and all sorts of other telco services as well as part of the overall envelope that we provide the customer.
So
Just a fun comment.
I'm really glad that you brought that up, though, because I'm always hesitant to mention storage networks to these guys.
I brought it up. Yeah.
So I'm glad you mentioned it, because I would have said it otherwise.
So one of our investors is Highland Capital. Highland Capital has had until recently a partner by the name of Peter Bell. Peter Bell was the founder of Storage Networks, one of the two co-founders. And when we were doing the pitches for the initial round VC, it was actually very funny because I think we only got through about 5 minutes of the pitch. And the minute he understood what we were doing, it was a completely different conversation. And he just started telling us all the things that went wrong and all the things that we should do. And I mean, so you could imagine it was a great conversation.
Yeah, but that was really the problem. Another big problem with that was that there just wasn't all that much fiber in the ground. And they were lucky to find it in Houston, but there just wasn't all that much, like in Boston or someplace else. And so now, that's really the limiting factor, I think, in this solution is to make sure that you've got the bandwidth to have that latency.
So we've and we've done this. Now we're actually we're selling across a number of different metros, and we have found it to be remarkably consistently cheap to operate in them. So here in Boston at our POP, we have I think at this point, last time I checked, it was 79 or 80 different options for fiber connectivity.
In Boston?
In Boston.
From that building right
From that building. So our point of presence is a block from here. So you can imagine the marketplace economics that delivers for you. You have 79 possible options, and then you have a point B somewhere. There's almost certainly 2, 3, 4, 5, maybe a dozen different options to get a single 1 millisecond path from the POP to the customer. And so the economics are very interesting from a competitive standpoint.
Well, the same was true in New York, in DC, in LA. So now today, when we start looking across the country and then the world, look at Singapore, look at Tokyo, right here. There are lots and lots of cities where you can go. If you were to x-ray the ground and look at the fiber, same kind of picture, different details, different carriers, but Switzerland, I mean, lots of places across the world, this is true now.
I remember the metro areas being pretty well wired,
Yeah.
but you had to go, if you wanted to do long haul OC48 or something like that, an OC12, you had to, Broadwing was a name that you had to call that.
Oh, I remember them.
Right? WorldCom or whatever they called themselves that year.
Yeah.
MCI, I guess, right? But I mean, now it's to your right, to the point, it's, what'd you say, 80 of them out of one building? It's crazy.
Yeah, so it's the economics are really interesting. This is one of the great learnings of building the company, is that we started to see a lot of very interesting connectivity sort of marketplaces. So depending on what building you are in, if you're in certain buildings in New York, in Ashburn, Virginia, or here in Boston, getting a cross-country connection is less expensive than getting a giggy internet connection locally. So it's a 10 gig. It's really interesting.